Hey, yeah, Alex from Blue Lightning Software here. We're just going, I just wanted to do another demonstration of what could go wrong. A couple of things I was testing with. Say Woot has been deleted, so you won't see this. But, yeah, just testing certain things. Here we go. It's to do with tasks that we created yesterday using this configure await. We then perform complexio, some complex, well, you know, not complicated, but goes into quite a number of iterations, of a mathematical multiplication kind of square down thing. And we were showing how if we use a task and async it using either this configure await or we task run it to insist on a separate thread, or we use this to insist, well, to say that, you know, don't go back to the main thread, use other threads, another thread, then it can perform the mathematical stuff on different threads in a very, you know, and save quite a bit of time overall. If you spread out, you know, like 10, 20 threads, depends what kind of core system you got on your CPU, but practically always on a modern computer, they'll be miles quicker, which it was by about a factor of 10 just doing this kind of math. Now, obviously, tasks, what I want to lead on to are the job system and say, oh well, this must do it better than tasks, and we could compare the time of those. But what I wanted to look at in this video is to show that there is a different, what could go wrong actually is when you start referencing the main thread. Now if you consider that Unity is like a single thread, there's just one thread, okay, and that's it, that's the Unity thread, okay, it's running in one single thread. Now anything within Unity cannot be accessed from outside that thread. That includes just reading the position of the transform of this is just a mono behavior that this test stuff is placed upon. So whilst this stuff, this mono behavior can call tasks on other threads, okay, it cannot reference its Unity API or any Unity API stuff from other threads. So once it has launched this task delay and said go to any thread on the way back using configure await, what it said is now on a different thread. It cannot even read its own transform. So let's save that. Let's just put this in to the test. It's you'll see it here. The error will appear. It's so simple. It's just trying to read its own transform. But let's press play. Let's watch this. Now, if you watch the previous video, this would perform the math calculation with reference to nothing outside, nothing within Unity API, or, you know, no game objects or anything, even though launched from within this game objects here, test stuff. Let's press it. Unity exception. Get transform even can only be called from the main thread. Okay, blah blah blah. Yeah, that is purely because of that configure await. So if we comment that out, the delay, the structure of this means that task delay is running on a different thread, but when it returns to the thread it was on. Oh my God, I've blown up Unity. Is it telling me I've blown up Unity? That thread's never getting killed. Oh no. Oh wow, man, blown up Unity. See how nasty this could get. It didn't do this earlier. is it that there are 500 of those? They not killed themselves yet on errors. How many were there? 10,000. And they're all going to throw an error. I'll just kill that. Okay, so you can see the problem that can occur. This is why you've got to be careful with your threads. So we'll get that back. Hopefully that killed all processes attached to it. There's still some running in the background. Oh no. Who knows? Oh, they'll end sometime. Alright, we're loaded. So here we go. Back to test stuff. Now this is the safer one. It will be fine. Let's prove that. At the time. Here we go. So yeah, it's just gonna run it. We don't need this complex math actually. I don't know if that's slowing it down. I think I commented it out. No, it's still there this time. Did last. Okay, so there we go. Tasks. Okay, so that's the same. It performed it, did the timing, which, you know, you can see what was going on there in the last video. It just didn't have a problem. It went from this delay, which is spun off to a different thread, so that the delay itself isn't locking it up. It comes back and returns to the main thread where it cannot access all this Unity API stuff. So if it now did Complexio after that, if it went into the mathematical stuff following this, okay, it would still be on the main thread. Now, what I was thinking is, it probably is a lot better if you wanted to do this kind of thing. Here's how ultimately how I would possibly do it. I would possibly do this, all right? And I think this would run correctly. Why doesn't it like it? Oh no, it's because I don't know anything I'm doing really. Yeah, anyway, alright, so yeah, how are we actually going to do that? I think we'd actually have to do this line would actually be directly Complexio. Yes, so rather than trying to do it as a separate spin-off task. So I'm still kind of learning these, to be fair. Yeah, since the first tutorial I'm kind of picking these up. So what have we done? We're saying now run this on a separate thread, so it can now take any mathematical function and run it on a separate thread. When that returns, is probably possibly the best way to approach this. Do the delay, it's on its own one. It comes back to the main thread. We can access again the Unity main thread because it returns from here to the main thread. Hold on, my phone. Hello. Oh, hello. Okay, I'll be down. All right, thanks a lot. Cheers. Bye. Okay, I've got to dash out. Well, let's just test this. What I was going to show, I'll have to come back later and show you the other approach. I just wanted to check that this would work in the same style. I mean, this makes total sense to me, but there is another way that I want to demonstrate later. Okay, so this should work. This should run this, come back to the Unity thread, main thread, and then do the math on a separate thread. Does appear to do that quite quickly. That's so fast, is that actually doing? It's too fast. I think if let's put more iterations on the math. Yeah, that was the kind of speeds. Now, if you did this, it will be invoke on 1,000 even. Like this is invoke trying that. It's getting slower. Can you see? All right, let's do 10,000. See how long this is all locked. It's going to take like 11 seconds. The tasks still at 1 second. So we can see that this is how I would probably do it. I'm going to show you some other method when I return, but this works. You know, you do your delay, you come back to your Unity main thread, you farm out the math work using task run complexio like this. So the mathematical task is now multi-threaded. You can control the timing of it by, well, it's saying await, so this doesn't finish until that says await. You have a handle on that task. You can control task completion and say, all right, so we could farm out tons of this math and come back and you know, wait for all those kind of things. When all, I think it is, we'll look at that. But that's comparable use of tasks to do something like the job system is like this. This task run is very similar to running a job, except you don't. All right, what's bad about it? We're not using burst compile. I'm not sure if we could even put just like burst compile on this, and it would work possibly. You have to come back to me on this. I'm going to look at this later. Try and get some time comparison. The task versus jobs is another thing. But I wanted to, there is a different way to do this that I may want to show later. But I've got to pop out now. So thanks for watching this one. And I'll come back and probably add to this in a second video.